Here's example C2, our next example. So this example has in the integrand x squared plus 4. So that's of the form u squared plus a squared. And the substitution that we'll do in this case, u is equal to x and a is equal to 2. Here we have 4, 2 squared. The u substitution that we're going to do is u equal to a tan theta. All right, so in this case we have x equal to 2 tan theta. Now taking the derivative, dx is equal to 2 secant squared theta d theta. And even though we don't have a square root here, this trig substitution is useful. All right, so let's go ahead and do the substitution. All right, so here we have for x squared, we have 4 tan squared theta plus 4 squared. And for dx, we have 2 secant squared theta d theta. All right, let's just rewrite this a little bit. We're just going to factor the 4 out. So we have 4 tan squared theta plus 1. And tan squared theta plus 1 is equal to secant squared theta. So we're going to replace that with secant squared theta right there. All right, so let's see what do we have here. Again, 2 secant squared theta. And then here we have a 4, we'll square it, that's 16. And secant squared theta will square that. That's secant to the 4th theta. All right, and let's divide over here. So here we have 2 over 16. Let's write 1/8 on the outside. And here we have 1 over secant squared theta. One over secant squared theta, that's cosine squared theta. So we have 1/8 integral of cos squared theta d theta. And we saw in the previous problem how we integrate cosine squared theta. Okay. We said cosine squared theta is 1/2 1 plus cos 2 theta. All right, so we're going to use that substitution again. And we'll integrate like we did before. That's theta. Let me actually integrate it now. Okay, we're actually integrating at this point. So we have theta plus 1/2 sine 2 theta. Again, the derivative of sine 2 theta is 2 cos 2 theta. So multiplied by this 1/2 and we get cos 2 theta. All right, so there's the integral. Okay. And we'll substitute back like we did last time. All right, go ahead, look at the original, x equal to tan theta. Let's write that over here. Let's write x over 2 equal tan theta. And again, we're going to put, for sine theta, we're going to put 2 sine theta cosine theta. All right. Here's theta, x over 2, opposite over adjacent. So this third side over here is 4 plus x squared. All right, let's do our substitution, and we have 1 over 16. For theta, we have arc tan x over 2. And here we have sine theta, cos theta. Sine theta is x over, opposite of our hypotenuse, x over the square root, 4 plus x squared. And for cosine theta, 2 over the square root, 4 plus x squared. Okay, plus c. Sometimes it's nice to check our solution. This solution, when differentiated should give us the original integrand. All right, so let's just see. It doesn't seem very likely that the derivative of this will simplify to 1 over x squared plus 4 squared, but we'll see that in fact it does. So you can skip this part if you want, but if you like to see the check, then continue and watch. So here's the check. So we're going to write y is equal to 1 over 16 arctan x over 2 plus, and here I'll just multiply that out, 2x, and here I have 4 plus x squared. Multiply those two radicals together. So we're going to take the derivative. So here we have y prime. Okay, so I'll keep the 1 over 16 on the outside. The derivative of arctan, okay, so that's 1 plus in the denominator, this thing squared, that's x squared over 4. The derivative of x over 2, that's 1/2 here in the numerator. Okay, and then we're going to differentiate this. We'll use a quotient rule. Okay, so that's 4 plus x squared squared. And here we have 4 plus x squared times the derivative of the numerator, that's 2, minus the derivative of the denominator, the derivative of this denominator, that's 2x, times the numerator. All right, so let's continue. Let's first of all simplify this first fraction over here. All right, what we'll do is we'll multiply top and bottom by 4. Okay, so here we get, in the denominator we'll get 4 plus x squared, and in the numerator we get 2. Okay. And here we get 4 plus x squared squared. Let's see. And the numerator, I guess we'll just multiply this out, and we get 2 times 4, that's 8, plus 2x squared minus 4x squared. Okay, we're going to actually combine these two fractions. First, let me rewrite this. It's 8 minus 2x squared. Let me just write it on top. All right, let's combine these two fractions. The common denominator is 4 plus x squared squared. So here we have 2 times 4 plus x squared. Okay, plus 8 minus 2x squared. And then simplify this numerator. Okay, and let's see, this numerator simplifies. Here we have 8, and here we have an 8, and here we have a 2x squared minus 2x squared. Okay, so this simplifies to 8 plus 8. This whole thing simplifies to 16, this numerator. And this 16 cancels with that 16. All right, and we do end up finally with 1 over 4 plus x squared squared, which is what we expected, our original integrand, and that's the check. Okay, let's look at C3. Here we have the integral, and on top we have a square root 9x squared minus 4 over x dx. All right, now this square root is of the form u squared minus square root u squared minus a squared. And what we do here is we put u equal to a secant theta. So that's what we'll do. We'll put here our u is equal to 3x. So we're going to have 3x. And our a is 2. 4 is 2 squared. 3x is equal to 2 secant theta. Okay, so we have 3 times dx is equal to 2 secant theta tangent theta d theta. All right, so let's do our substitution. So under the square root we have this, square this, and we have 9x squared, so we'll square this side. So we have 4 secant squared theta minus 4. And over x, okay, x, divide both sides by 3, x is equal to 2/3 secant theta. So here we'll put 2/3 secant theta. And then for dx, we put actually 2/3 divided by 3 again. So for dx, we have 2/3 secant theta tangent theta d theta. All right, so this 2/3 cancels with this 2/3, so let's do that. This radical simplifies. All right, I think we'll do part of it in our head. This is 4 times secant squared theta minus 1, and secant squared theta minus 1 is tan squared theta. So what we have over here is 4 tan squared theta underneath the square root. All right, so this is the square root of 4 tan squared theta. So that's this simplifies to 2 tan theta. So let's rewrite this. So here we have 2 tan theta. And let's see, these 2/3 cancel, and let's just cross off the secant theta cancels with this secant theta. So here we have 2 tan theta times tan theta, this one. Okay, so that's the integral of 2 times tan squared theta. And how do we integrate tan squared theta? Well, remember, tan squared theta plus 1 is equal to secant squared theta. So another trig substitution, using that same trig identity, let's do that. So we have secant squared theta minus 1 over here. And secant squared is the derivative of tan, so we'll be able to integrate that. So this is 2, and here we have secant squared theta minus 1 d theta. All right, so that's equal to, okay, the antiderivative of secant squared theta is tangent theta minus theta plus c. And now we have to substitute back. So let's look at our original trig substitution, and we'll solve for secant theta. 3x over 2 equals secant theta. Let's write that. Okay, so we have 3x over 2 is equal to secant theta. So for theta, we're going to have arc secant of 3x over 2. We'll do that. And what about tangent theta? Well, we'll have to draw our triangle to figure out what tangent theta is. Now secant, remember that secant's 1 over cosine. So this is hypotenuse over adjacent. Hypotenuse, if I put theta here, hypotenuse over adjacent. Okay, and so this third side over here, according to the Pythagorean theorem, is 9x squared minus 4. So using this, we have tangent theta is this side, 9x squared minus 4, square root 9x squared minus 4, divided by 2. All right, so let's substitute back. And so for tangent theta, we have opposite over adjacent. That's this square root 9x squared minus 4 over 2. Minus, and theta, for theta we have arc secant 3x over 2 plus c.